So this is different from everything else. I have no slides. I don't like slides. I make games. Epic make games. I'm gonna make game. Okay. I've got like 20 minutes, so this is gonna go really fast, probably too fast. And I don't know how far I'll get because 20 minutes is really too short. But we'll see how it goes. And I hope you pick up something out of it anyway. So the idea is to kind of make a very basic game from scratch. I do have certain things prepared somewhat, but to kind of give you an overview of what it's like to make something in Unreal, to kind of go through the process of building something. Okay. So before I start, who of you have tried Unreal Engine 4? Okay. Nice. Good. Is there anyone who doesn't know what Unreal is? Great. Perfect. It's always easy. Like, I'm just going to start and build something. I'm going to build an endless runner game. So it's a game where you continuously run forward automatically. You can go left and right, kind of. You can slow down the player as well. And there's some obstacles coming at you have to avoid. And there's some points you can pick up. And that's basically it. And again, we'll see how far we get. So first thing I need is I need to slightly prepare it. You can see what I have here is a default level, by the way. There's nothing in here. It's just a sky with, this is the player start, the default start location. And there's a ground underneath. So let me just very quickly scale up the ground because I'm going to need a bit of space to mess around with it. Right, I'll just scale it up. And then let's start setting up the game. Now, a lot of what I'm going to do is based on Blueprint. Blueprint is our visual scripting system. Everything can be Blueprint. So it's somewhat like it's like a prefab maybe in a way. It can contain meshes, it can contain sound, particles, anything else, but it also contains a lot of visual scripting. So I need 2 of them. This is just preparing here. It's a hierarchical structure, so it's based on a certain parent class, and that brings in certain functionality. So I'm going to have one based on game mode. Now my names, as always, are terrible. I'm like artist names. Terrible name game mode, like that, for example. And I need a second one, and this one is based on a character. I probably shouldn't have called it terrible. It's not very nice. Anyway, so now we have both of these, and again, I'm just preparing still. I'm opening up the game mode. So here we have the game mode. You can see there's nothing to see here really. We don't really need to do anything with most of it. But on the right side there, not sure if you can read it, but it says default pawn class. So basically the game mode is controlling the basic rules of the game, but it also controls what kind of player class is being used. What kind of HUD class is being used. It basically controls which subclasses it uses for the various parts of the game and the functionality. So I'm simply going to enter the player I made. That is default pawn class, so that's the one I just made. That's it. And then I'm going to tell the level or the project. I'm going to go for the level, but either goes. I'm going to tell the level. So world settings, game mode override. Please use this game mode. Okay, that's it. I'm just making sure it uses the things I've made, and I will play it. And nothing really happens, but it plays. Might be hard to see, but it is actually running. I mean, I can't move, I can't do anything, but it's using the player I just made. Let's go to the player. Now here we have the player. You can see there's a number of things in here already. You can see on the left side here we have the components, and a lot of this is inherited because when we made the player, we picked character as base class, right? That's the C++ base class above it, and that one already brings in certain functionality, like the collision. This is the collision of the player. The arrow is just showing the direction, and then there's a mesh here, which is the model of the player. You can't see it right now because it has none. It doesn't have anything assigned here. But that's basically coming in because of C++. Let's do the movement first. So I'm going to leave this be, and I'm going to move on to the visual scripting aspect. So I click event graph. Let me delete some of the default nodes here, empty space, and let's have we need a certain action, So I have an action called jump. Action events called jump, and I have a function called jump as well. So we just connect jump to jump. And we get this. Very quickly play it. You can see I can jump. Cool, isn't it? Nice. So what just happened is that, again, because of the C++ parent class, we have character movement already in it. Okay. The character movement component, it contains all of the settings of the player, including how fast does the player run, can you swim, can you fly even, how high can you jump, all of that. For example, it says here jump set velocity 420. If I make that 800 and I play again, I can jump higher. So yeah, this is higher than what I had before. And also the jump action I had in the beginning there, I could technically, I guess, do this spacebar and on-press spacebar jump, but then we're hard-coding spacebar, which is probably not great. So instead what happened is that I did project settings, and here it says somewhere input, and here it says action mappings, and here it says jump, see? And here you can see spacebar is connected to jump. If I type something else here like UFO, I don't know, for some reason, and you connect that to some random key, I'll just click something here, and then I go back to Blueprint, you can see I would now have a key called UFO. It's just linking it, so you don't hard code in the keys. Cool, let's do the next step. Move right, similar setup. So you have an event called move right, and I'm going to add movement input. We'll do that. We'll do this. It's going to move on direction y1, because for us y is left and right. The player is facing x plus, so y plus is right, y minus is left, and it's going to scale that with x's value. Basically, this one represents both left and right at the same time. It represents both the D and the A key at the same time. If you press A, if you go left, it actually outputs -1, so it inverts this number. Long story. It's too much for 20 minutes. So let's try this again. And you can see I can now go left and right. So we're starting to move. It's nice. You can see all of this run in Blueprint, by the way, as you play as well. Small screen, but see the game is running now. You can see as the game is running, you can see the Blueprint execute. See when I press jump, you can see the jump execute. You can read the value, the values in it as well, and so on. Next step, let's make the character move forward all the time. So I'm going to do this per tick. So for every frame, keep adding movement to the player. Because you don't control your forward movement yourself. Basically the same here, so add movement input. Let's just copy that. And let's add that to tick as well. Scale value in this case simply 1. Direction is x1, not y1. So let's flip them around. And that should work. Let's try. You can see we're moving forward without pressing anything. And I can still go left and right and kind of control the player a bit. That's working as well. Then let's make sure that when you press backwards, you kind of slow down. So you can kind of slow down the player. If there's an obstacle coming, you have something, you can slightly control the speed. Move forward. We'll take an axis value, move forward here. Basically what this is doing, I can look at it, this one here. Here you have axis value for move right. See, if I would do this, this green thing is the same as what's being outputted here. It's just in a separate block. So this will be 1 if you go right, -1 if you press left, but if you don't press anything it will be 0. And it's the exact same thing for moving forward or backwards. +1 for moving forward, -1 for moving backwards, 0 for not pressing it. So because I then know when I press backwards, when this is -1, I'm going to first of all clamp it between minimum -1 and maximum 0. Because again, it goes from -1 all the way to 1. We don't need the 1 aspect. We only need the -1 to 0 aspect. So we clamped it out. Then I will do absolute. So flip it around again. There's other ways of doing this, but this works for me. So that works. Now it's absolute, so it's a positive value again. And then we have a lerp, linear interpolate. X on the alpha from that. And this is the axis value. What happens is it will go between value 1 or 0.25 for scale value. Right? So if you press back, if you press -1, this will output 1, so it will use value B, so it uses 0.25, so you go 25% of the speed. If you don't press anything, this will output 0, so it uses A, so you use 100% of the speed. So you can see when I now, if I have my mouse somewhere, see if I press backwards, you slow down. That's working as well. Then let's make it a bit more interesting and let's make the game speed up. The longer you play the game, the faster it's going to run. Now in the character movement that I've shown earlier, it says here somewhere max walk speed. Max walk speed, that's your actual speed. So let's say that's 200 to begin with. That's how fast you go. But over time, you want to continuously increase that number. So what I'm going to do is I'm going to take, I want to have this number in here so I can do something in Blueprint. Right, I can't really drag this. This doesn't really work. I can probably find it in here. But the more correct way of doing it is by dragging in character movement. It's loading. Character movement in here. And you can see this thing now represents the component there. The thing with Blueprint is it's completely context sensitive. Right, so if I right click here, this menu is different than if I were to drag from here. This is a different menu. Let me see if I can find a more obvious one. See, this is a much shorter menu. Where you drag from, it only shows the possibilities you can do at that particular point. So it kind of helps you to figure out what you can do. So because of that, I'm going to start dragging from character movement because that contains the walk speed, and I'm going to get the walk speed, and I'm also going to set it twice. So we're going to set it like that, but we need it continuously increasing. So I'm going to do an f interpolate, float interpolate from whatever it is right now. So from current to target, let's say something really fast like 4500. And it needs a delta world seconds. This is just for the updating. And interrupt speeds, I don't know, let's say 40 or so seems to work okay. That's it. There's probably a lot of information to take in, but I hope you're starting to get a little bit of an idea of how you go about making something. And you can see if I play this, it goes very slow in the beginning, and if you wait a bit, it should be speeding up the longer we wait. So it's starting to speed up already, so that works as well. And again, you can actually see it. I'm going to follow the world now, but you can even see the number increasing there in it as well. So you see everything. You can see the number going up and up and up. And I fell off the world. Details. Good. Let me go back to... Not that. Let's see what else we can do. We can probably add some pickups. So we need a barrel pickup and we need a point pickup. Let's do that very quickly. I'm going to do a new blueprint class again. Based on nothing, actor is the topmost class. It doesn't really do anything. It's above everything else. So based on actor, barrel pickup. Let's do the barrels first. Stuff explodes, more fun. You open it up. It's completely empty. You can see there's nothing inherited here. There's a sphere thingy here, but it's just placeholder to not have it totally empty. It doesn't do anything. So I'm going to add a sphere collision. This is basically the trigger. If you walk through this, it will trigger. And in here I'm going to say overlap all dynamic, let's say custom, and overlap only with pawn. Basically I'm making a trigger that only responds to the player. Let's do it like that. Sorry. Then let's add the static mesh to it as well. So here's the model of it. And here's the barrel. So I have a barrel already imported. We have a lot of content examples, by the way, you can just download for free. This is one of them. Obviously not just the barrel, a lot more than the barrel, but the point is there's a lot of stuff you can download. So we have a barrel available. That's what I'm using. And let's add fire to it, because otherwise it's not fun. So here's fire, and it's set to fire. This is just one of the default particles you get with every project you make. I'll show you that here as well. Just fire, built-in particle editor. S with everything else. So that goes there. Let's make sure the barrel doesn't have any collision, otherwise you would get stuck on the barrel before hitting the trigger. So I'll do block all dynamics set to no collision. Covered, and let's slightly increase the trigger radius. So we have something like that. Then I need to script it very quickly. So I'm going to take the sphere, the trigger radius basically, and do add event. On component begin overlap, and in here I'm gonna do, let's do the most basic thing first, destroy actor. So when you touch the trigger, it hides or it destroys the barrel. Let's very quickly try that. It's loading, coming in. There we are. Let's place that somewhat in front of the player. Let's have a couple of them. Let's play that. And you can see it disappeared if I hit it, but that's about it. Let's make them more interesting. So let's do play sound at location. At location. And spawn emitter at location. And where it should spawn it is get actor location. So get the current actor location, which is get location from self, get the location of this object, spawn it there, sound is explosion, Q, particle is explosion. Sorry. Let's run it again. And now I would have this, you can see it explodes, there is a sound and there's a particle exploding. We're getting there. I'm not sure how much more time I have, 5 minutes left. So what I'm going to do to wrap up, before I have maybe 1 minute for questions, like one question, is I'm going to very quickly assign the character model as well, so it looks a bit nicer to present. So I'm back to the player, and in here, as mentioned in the beginning, mesh is empty, right? So now if I assign one of the meshes I have, it's loading, for example, the boy here, against one of our sample contents. Let's move him down some, because the collision ends over here. Let's rotate him, because he should follow the arrow. And there is no camera. If there is no camera, he takes the default location, which is in the middle of the body. If I add a camera to it, he will automatically take the camera instead. So I'm going to add a camera. And to do it correctly, very quickly, spring arm as well. Spring arm allows you to offset the camera, basically third-person cameras, collision controlling, all of that. So we have that. Something like this. Let's play that. We're not going to have any animations. That would be one last step. So at least we have this now, which is rather fun. I can see it explodes. So the animations. Here it says use animation mode. Sorry, use animation blueprint. And then it says animation blueprint generated. Class says none. So I don't have anything filled in here. So I'm going to assign one of the pre-made animation blueprints I use. So even for animations we used blueprints. Everything is very consistent. All of the tools we built, all of them we've built ourselves. Everything is used, looking exactly the same, works exactly the same, works on every platform. It's pretty bug-free. Obviously, something can go wrong somewhere, but kind of just works, right? And it's easy to learn them. I can very quickly show you this one. It's easy to learn them because they all look the same. This is what controls the animations. It's basically built-in state machine and some other things. Actually, even this is blueprints. And it's the animation tools. Everything is consistent. Everything is readily available. Anyhow, by having assigned this one here, you can see he already has animations. He already has a blend state and everything else. See, he will speed up and he will start playing a run animation if he goes faster. And we have the whole thing. And you have a jump animation and so on. Good. I think I have 3 minutes left. Do you want to do questions for 3 minutes? I fell off. Are there any questions for 3 minutes or anything you want to very quickly look at?
When your project grows, like gets bigger,
Yes.
how can you split and give each part to different developers, and after that, how can you like assemble it to one project back? Understand?
All of the files we have are different files in Windows. I mean, okay, here we have a texture. I can just right-click it. You know, show in Windows, where is it? Show in Explorer somewhere. Show in Explorer. See, it's just different files. So first of all, that's easy. We don't have the packages anymore we used to have, for example. With blueprints, there's a lot of advanced stuff built in that allows you to split the blueprints up in a lot of different files, a lot of different functions. I mean, not everything has to be in one particular giant blueprint, right? So if you, and plus you can move anything to C++ as well, as you wish. So there's so many tools built in. I mean, it's not just a fancy tool that we built. You know, look, you can make simple games with it if you draw some wires. You know, we have a background in AAA development for a very long time. This has to work with 200-300 people teams. So we're definitely going to make sure you can do it. And that goes for every other tool we have. It goes for the material editor as well. We've had a material editor since 2006, unlike certain other engines. And you know, we've had it since then, and we already passed the stage where, yeah, you have visual scripting. We had visual scripting since 2006, by the way, as well. You know, we're past that stage. Well, we're now at this stage where we can really say, like, look, how can we make this a lot better? How can we make sure this actually works on a very big scale? How can we make sure this works really user-friendly, and so on? So it's too much for me to go into exactly how it works, but trust me, it's there.
Which version control would you recommend?
I mean, we use Perforce as most big studios, but I mean, SVN works as well. You can see here at the top, there's a button built in, source control. So that's, it's built in. If you enable it there, you see it in the content browser, you can see who has which files checked out and so on. We have Subversion, Perforce, and Git as well. So, and there are no meta files or anything else. Everything's just one file. You check that one file out, it's fine. It can handle read-only and so on.
So my question is more from the program management side. I mean, it's a fantastically powerful tool. I've used it in the States.
Yeah.
In Europe, I'm finding tons of Unity developers, but not tons of Unreal developers for my project.
Yes.
What's your theory?
It's partially regional as well. If you look at an engine like Unity, they obviously started in Denmark. They're very strong in Finland as well. I mean, it depends on the industry. If you look at a country like Finland, there's a lot of mobile games. There is a certain, stronghold of Unity, for example, to pick that engine. I mean, so there's a lot of those kind of things going on. And obviously, it's just the fact where you have your most people. We have most of our people, like 90% or so of our people are in the United States. So you end up having a lot more relationships and a lot more contact and all that in the States, so therefore more people end up using your engine, and it's a lot of factors, I would say. So, yeah. Good. I should probably wrap up. That's my name, by the way. I didn't mention that. Details as well. Okay.
Please give a hand of applause for Sjoerd.